Hi, this is Mark Kemper with EMS, and this is the new Creaform GoSCAN Spark 3D scanner. So let's start by talking about the specs of the new GoSCAN Spark 3D scanner. Now, this new scanner replaces the GoSCAN 20 and the GoSCAN 50. The GoSCAN 20 was meant for smaller parts, had a smaller scan area, higher resolution, higher accuracy, and the GoSCAN 50 had a bigger scanning volume or area, meant for medium to large size parts all the way up to car size. The new GoSCAN Spark takes the technology of both those scanners and puts it in one and improves upon it and makes it even better. So, for example, it has a ability to scan up to 1.5 million points per second. It uses 99 structured lines, and you'll see that here in a minute, which is different than the older technology. It has an accuracy up to 2/1000ths of an inch and a mesh resolution up to 8/1000ths of an inch, and it still scans in color just like the previous generation. It's got a new kind of look to it. It's got some new sensors and cameras and stuff. We'll talk about all of that here in a minute, but it's definitely an improvement, and the ability to put both of those technologies now into one scanner is pretty exciting. So let's get set up and we'll scan some different parts and kind of show you how it works and get into more of these features we've just mentioned. So the GoSCAN Spark has a lot of uses. It's been very popular in the world of like art and geology and historic preservation, especially with the color capability, being able to capture that. It's also been very popular in the medical industry for prosthetics and prosthesis. A lot of people use it for industrial design, where maybe they've made something out of clay or wood or something else and they want to scan it and turn it into CAD. So it has a lot of great uses, and we'll talk about some of those as we go along. So let's start here with this statue, and the first thing you may notice is there's no targets on it. Some of the Creaform scanners do require targets. This one does not. Now, it can use targets, and there are many times we want to do that, and we'll get into why and what examples you would want targets, but it doesn't necessarily have to use targets. So to use the scanner, there's some buttons on the side, and we just long hold the button to basically tell it we want to start scanning, and then we push the button to start scanning. Now, we hold the scanner about 12 inches away from the screen, or sorry, the object we want to scan, and we just kind of start moving around, okay? And you can go up, down, sideways, whatever you prefer. And as I scan, you can see on the screen here the scan lines. And as I mentioned earlier, there's 99 scan lines or projected light lines. And one thing nice is as I'm scanning, if I get too close to the object, you'll see it turns red, and if I get too far away, it turns blue. So that lets me know where that optimal depth of field is to scan this object, and you can see how fast it is. Now, like most scanners, this is line of sight, so you want to kind of articulate your arm around and move back and forth, but you can see how fast it can capture. Now, we are doing right now what's called geometry-based alignment. And what that means is it's basically sampling this part multiple times, dozens of times a second. So it's projecting these lines out, and then these cameras, there's two of them here, that pick up the distortion of those lines, and that's how it gets the 3D shape. So as it's sampling that, it's aligning each scan by looking at the geometry. So on a part like this that has lots of shape to it, it's very easy to align the geometry. So every scan can be quickly aligned to each other just by basically fitting the geometry. So as I move around, there's no issues with it getting lost because, again, there's so much shape. So anything like this, anything that has a lot of shape to it, it should be fine, and you shouldn't need targets whatsoever to grab it. So you can keep going around it. You can't overscan it. If you go over the same areas over and over, it's not going to hurt. Okay? And then at any time, I can stop scanning and take a look at it. Okay? So if I come over here and take a look at the screen, I can zoom in and look at it and see, if I have everything. Now, since I'm not using targets, when I stop scanning and want to start scanning, you kind of see this area on the screen here. I need to start scanning in that same spot because I've got to start where I left off. I've got to match back up to that geometry and continue scanning. So when I go to scan again and I push the button, you can see it locks on. Now sometimes it can have trouble doing that, and we do have a great way to go back to the part. So let's say, for example, I got lost and was having trouble getting the scanner to recognize that area. I can actually come in here, let's zoom it in, and if I right-click and say Resume Scan, I can actually pick an area, and you can see what it does, and then I can go ahead and go to a different spot and start scanning again. So that's nice if you ever get lost. So again, I just keep going around it basically until I'm done, and if I long hold the button here on the scanner, it's going to actually complete the scanning process. And what it's done is you can see it's finished scanning. Now the scanner underneath is collecting points, but points are very difficult to look at. So what we do is we take all of those points and we polygonize them or turn them into triangles, okay? And that's what you see here on the screen. So for example, if I come in here and I click wireframe and triangles and I zoom in, you'll see what this is. It's just a bunch of small triangles, okay? And those are basically the edges. So we'll turn that off. And if we go back and you can take a look, right now I'm set at 0.5 millimeters, and you can work in inches or millimeters. I'm set in millimeters. So my mesh resolution right now is 0.5 millimeters, okay? Now it always scans at the highest accuracy it can scan. This is just the mesh or the fidelity of the part, okay? And the nice thing is I can turn that up and down because, depending on the size of your file, this can get very large. This is already 2.5 million triangles. And let's say I just don't need that high of a resolution. I'll set it to 3 just to kind of show what that means. So underneath is that raw point cloud. And what the software is doing right now is actually going back to that raw point cloud and repolygonizing it, this time down to 3 millimeters. And you can see what happens when we do that. The model looks much softer. It's not as much detail. And you can see why, okay? So because I've turned that down. And depending on your application, some people also use this for simulation and analysis like FEA or flow analysis, CFD, things like that. They may not want a super high resolution model. Same with animation and simulation. They may not want that. So you have complete control of that as long as you save this session file in the VX Element software, which comes with the scanner. You can open it back up and change this resolution up and down to whatever you want. So that's a really nice feature. So as long as you take your time and scan it real well, you'll be able to do that. Now, let's go ahead and, we notice here there's some spots we don't have scanned. We can always go back and hit Start Scan and continue scanning. And again, it's going to go back and show me where we left off. So I can either try to grab back onto that place or reset to a different place like we did last time. So as long as I can try to grab that, and you can see how quick it is, and then I can go down and try to get into those areas, okay? Now every scanner like this is line of sight, so there can be times where it's just not going to get areas if they're really narrow or really small holes. Scanners just can't get everything all the time. But once we're done, we can hit Stop Scan, and then we can do things like decimate, fill holes, smooth the data. There's a lot of nice tools in the VX Element software. So, for example, let's go back to 1 millimeter. Let's go ahead and auto decimate. Let's slide this up to fill in some holes. You can remove isolated patches. That's kind of data floating out in space. So there's all these nice tools you can do. and you hit finalize, and it's going to do all of that now. So it's kind of a two-step process now. And the other thing you'll notice is on the GPU here, we've got a GPU and a CPU readout. That's because we're taking advantage of the NVIDIA graphics card. In this case, it's a P5200, and we're actually accessing and using that GPU. And that allows us to render things faster, to do a lot of this stuff much, much faster. So we can take a look at this now, and we can say, hey, you know, that looks great. I've filled in holes. I've done some smoothing, you know, whatever operations I want to do. And then I can save my session file. And then typically I'm going to export like an STL, or if I'm doing color, usually it's going to be an OBJ. So that's kind of the whole process. We can stop and start scanning and continue on. So let's set up now and do a color part and show you how the color technology works. All right, so we will take advantage of our statue here, and we've placed a motorcycle helmet on our statue, and we'll use that just to kind of hold it in place as we scan. So the scanner itself has quite a few different, as you can see here, sensors and cameras and so forth. So some of these are the sensors that pick up the 3D shape. There's also projectors with projected light, and then there's also a camera to pick up color as well. So when you tell it you're going to scan color, which is just a push button there in the software, it's going to use this camera here to pick up the color. So you really do the same thing as you did before, and now we're just going to capture color. So again, we'll long hold the button, and we'll go ahead and start scanning. So what you'll notice as you scan, okay, we'll start to see color. Now, one thing we haven't talked about yet is adjusting the power of the light and the speed of the sensors, okay? So I'm just taking the default here, but there's many times that if you're doing something dark or shiny, it just may not pick it up as well, and we might have to adjust it. So we're going to start and just see what we can get, but you're going to notice areas there, like on the back of this helmet where we've got like a black and white checkerboard. It picks up the checkers just fine, but is not picking up the white checkers, but not picking up the black, okay? And you can see here, we got to go a little slower as we get color. And also it's going to struggle a little bit because of the shape of this. It's much smoother than just the statue by itself. And that's what I was talking about, where targets can be handy, okay? And we'll show that here in a minute. So when I get into areas that aren't very descript, it has a hard time. Any scanner that works this way is going to have a hard time aligning that geometry. Now, there are scanners out there that say they don't need targets, but they end up putting like small pieces of tape or other things on the part so that the scanner can see them. So essentially that's a target, right? Anytime you're trying to lock onto something, you can call it a target, okay? So you can see as I move along. Now, there are a few settings I can change to help us, though, as we go along. So, for example, let's stop scanning for a minute. And I can turn semi-rigid on. Right now I'm using targets and geometry only, but I can also use targets, geometry, and texture, okay? So let's go ahead and click that, and I'm also going to crank my shutter up. Now, I can do this with the auto adjust command, or I can just manually do it. Let's go ahead and try it, because you can see there's a lot of areas, all the black, it didn't get, okay? So let's turn this up, and let's go back and scan and see how that does. Now again, we always have to start with where we left off, unless we, do that, kind of reassign the location or resume scan. Okay, so now you see as I'm scanning, I'm getting more of the dark, but may not be enough. Okay, so I can also stop scan, double-click this button here, and I can walk through different things like the auto adjust, and I can come over here and have it try to tune the power of the lights as well as the speed of the sensor. So now I'm holding it over the black area there, and you can see it's going to crank it up. Now, sometimes you can overexpose some areas and underexpose others. So what we may have to do on a part like this is actually kind of scan it at these two different settings, okay? But now I should be able to pick up the black, okay, because I've increased the power of the lines, the structured light, you know, and these are LED lights, so they're eye safe. And we just keep moving around. So now you can see we're starting to pick up some of those darker colors, okay? So again, when you're doing color, you definitely got to go slower because it's capturing so much information. Now we're capturing the color, and we have to assign the color to every one of these scans, and basically it's going to build a texture map, and at, you know, up to 1.5 million points per second, you know, taking a pretty high frame rate, you can get an idea of just how much data we're trying to pick up. So let's kind of move around here a little bit. And then we can, the beauty is we can start and stop at any time. Let's go ahead and stop, and we'll long hold the button on here, and that's going to exit the scanning process. And then that's going to allow us to kind of zoom in here and look at it. Now, we're not done. We're still kind of in this, it's kind of like a low-res mode when you're scanning. It lets you look at it, but until we actually finalize it, it hasn't done some of the other things. But it does allow us to zoom in and look at it, and if we think that looks pretty good, then we can go ahead and do our finalize, and then depending on some of those settings we've got set like we showed before, it's going to go through and decimate and fill in holes or whatever we've set. It's also going to go through and really apply the textures to the scan data, and you'll see when this gets done, the final file will be greatly improved. So it gives you this kind of low-res mode, so you can stop, look at it, keep scanning, and then finalize it. You're going to get the you know, the completed model, which typically is going to look better. Okay, so now it's done, and now if we zoom around and look at it, you can see how it looks. So it looks really good with that texture on it now, now that it's finished and finalized, okay? And at any point, I can come up here and turn the texture off and look at the underlying scan data. Now, I'm at 1 millimeter. I can crank this down if I want, down to that maximum resolution if I want. Just, again, depends on what I'm doing. Many times, if I'm trying to capture color, maybe I don't need it as high a resolution. But either way, I can crank this down. I can save this. But you can see it does a great job. You can zoom in here and, you know, clearly read the size of the helmet and some other things. So it does a great job in capturing color. Now, next, why don't we set up something that we're going to scan an airplane door where on one side we don't need targets, and on the other side we're probably going to need targets, and we'll kind of show what that looks like. So we've set up an airplane door here, and we want to use this example just to show you how fast the GoSCAN Spark is, and then also scanning with and without targets. Now, this again has plenty of geometry. We shouldn't have too many issues locking on and moving around. So again, as long as your part has a lot of geometry, a lot of shape to it, the scanner should work great. So let's get started. I'll kind of talk as we go along. As far as the cable, it comes with a 10-foot cable, but there's a 25 and 40-foot cable. So if you're doing something very large, you can have a long cable, because it does have to be tethered to the PC at all times. But we're just going to start right here and just start moving around. And with that big 15 by 15 volume, you can see how fast we can move along here. So you can see the structured light lines, and again, you just kind of move back and forth. It's kind of like digital spray painting. We've got some readouts on the side here, again, that'll tell us if we're too close or too far away as we scan. And then we've also got the readout on the scanner itself, or up on the screen as you saw, and just continue to move around. And again, it's all line of sight, so it doesn't hurt to go back over it. And with this being so portable, being able to articulate your arm around to get into these areas, because scanners like to be perpendicular to the surface that they're trying to scan. You're just going to get a better return that way if you're perpendicular to it. So again, being able to quickly articulate around allows me to do that. And then we'll come up here. and get this in here. Again, if you get lost, you just go back to kind of a known place. And again, it's just, if the geometry is not very descript, it may struggle a little bit to find it. But you can always go back to a known place and get it. Let's come over here and get this sign. But you can see in a matter of a few minutes, I've scanned this entire airplane door. So there we go. And then again, I'll long hold, and that'll stop our scan. So very fast, very portable, comes in a small travel case. You can put it in an overhead. You could fly somewhere. In this case, maybe climb inside the cockpit of a plane and 3D scan it. So you just need a laptop and the scanner, and off you go. So let's take a look at our data here and see how it looks. So you can see very quick. I'm set at 1 millimeter point spacing right now, but you can crank that down to whatever you want. Okay. So looks pretty good, pretty fast, and we have captured a couple million triangles, so not bad. And then again, I can do smoothing, decimate, whatever I want, finalize it, and then save it. Okay, so that is scanning something that has a lot of shape to it. Let's take a look and try scanning the other side of this door and see what happens. So now we're set up and on the other side of the door here, and we're going to show aligning to texture and aligning to targets, and really kind of talk about what the best applications are, when you'd want to use which one. So if you look at now the outside of the door of this airplane, it's very smooth and not very descript. Okay, so for now we're going to kind of ignore the decal on here, and let's just pretend there is no decal and it's just smooth white. So we're going to go ahead and try to scan and see what happens. Okay, so if I go ahead and hit the scan button and try to move along, you can see it's blue, and it's really not capturing anything. It should be green right now. Okay, so what the problem is the scanner is sampling the geometry, and then as I move and it's taking other samples, there's nothing unique about each scan because this is so flat and not descript. So it's really having a challenge locking down the data. So we really have two options: putting targets on or using texture if there is one. Now, in this case, this has a texture on it, so we'll use it, and we'll show that next, and then we'll put targets on and show that. So we're going to come over here to the software and reset everything, and we'll go ahead and click Acquire Texture so you can actually see it, but we're going to come over here and say Targets, Geometry, and Texture. So we're going to grab all three of those, and we're going to go ahead and reset and scan. Now, another nice thing on the scanner is there's this nice strap which you can put. It's a nice kind of stretchy strap you can put around your hand. This is great, especially if you've got to hold the scanner down like this for a long time. But now we'll go ahead and scan. And now we're going to actually look for that texture. We're going to acquire it, and we're also going to then use it for aligning. Now, we can use it for alignment and not save it or keep it or acquire it, but let's just go ahead and keep it while we're here. Okay. So now by using the texture, you can see what happens. We get a nice scan. Now, we can still run into trouble. Let's go back here for a sec. Once we get beyond this decal and try to go up around the rest of this door, we may struggle because we don't have that decal to lock onto. So let's go ahead and stop this scan for a minute, and we'll go ahead and reset and put some targets on. Okay. Okay. So now we're going to pretend that the decal isn't there, and we're just going to look for geometry and targets. Now, we know if we try to do just geometry, it's not going to work. Now, the targets themselves come in a box, and they can be magnetic, or they can be adhesive like these. There's a light adhesive and a regular adhesive. These are the light adhesive. The regular is great for maybe parts that got oil or dirt or stuff like that on it. But they dispense easily out of the box, and you just randomly put them on the part. And they're retroreflective, So they're going to reflect back into the sensors, and they're going to look for them, and they're going to track, they're going to use them to track our movement. So the best way to think about targets is satellites in the sky. Okay, so we put them on here randomly, and as long as the scanner can see 3 of them, it can triangulate its position in space. Okay, and the advantage of targets is they allow you to go fast. It's the most accurate way to scan because you know, they're not going to move around. They're random on the part, as you see here. And because the scanner has such a large viewing area, you don't need a ton of them. So we'll target up just the same area and we'll scan again. Also, when we're done scanning, the software will remove them and fill it in. And if we're scanning in color, it'll actually remove them and fill it in with the color. So now when we scan, you can see we're not looking for texture. We're only looking for targets and geometry. And you can see how fast we can scan with those targets. Now, if we try to go up in certain areas, we may start slipping. We can always add more targets as we go. But the advantage of targets is they're the most accurate way to scan and usually the fastest way to scan because that just, you know, there's maybe 20 of them here and it can lock onto them very quickly and scan. So again, there's 3 ways to scan. Geometry only, where it's just looking and matching up the 3D shape as it moves along. The second way is targets and geometry, or just targets. And the third way is texture. So if you do have enough texture, even on a flat surface, you're able to lock on that and scan it. So it does give you a lot of versatility, and you can scan with or without the color for any of those 3 methods. All right, so now I thought what we would do is show scanning at a higher resolution and see how that looks. So I have this model of a drill here, and it's got some real fine detail on it. On the chuck itself, there's kind of a pattern on it, kind of a grip pattern. And then same with down on the handle itself, there's kind of some nice detail, and then the venting for the motor on the back. So let's go ahead and scan this, and we'll keep talking as we go and talk more about it. So a couple things. One, I'm using targets for this. And let's zoom in our display so we can kind of see a little better. And I've cranked it to the maximum resolution, which is 0.2 millimeters. And I'm going to start working my way around. Now, I've got targets on the table, and then you can see I've also got these little triangles. The targets on the table are great as I'm kind of aiming down. But as I start to roll over, it'll have trouble seeing those targets down on the table. So these triangles are great because they're more in the vertical view of the scanner. And again, anytime I can scan with targets, it just goes faster because it locks onto them so quick. And you can see the targets aren't on the part. I can just have the targets around the part. So as long as those targets are in the field of view, we can scan using the target acquisition. So using targets is always the fastest and most accurate way to do the scanning. So if it's easy enough to do, you can use targets. And we just keep moving around. Now, theoretically, we could definitely scan this part without targets. It wouldn't be an issue. But again, it's going to go fast because it can lock onto those targets quick. Now, I'm also scanning in color. We might as well grab the color while we're here. And we just keep going over it. You can kind of rotate the scanner because those scan lines themselves, these 99 vertical, or in the really actually horizontal scan lines here, it's for these sensors to pick it up. It's the actual convergence of where the projected light comes out and then the 2 sensors being able to see it. So down in some of these narrow areas, you want to kind of just rotate back and forth and try to adjust that view so that the cameras can pick up and see those lines. And the lines distort over the shape of the part, and that's how it picks up the 3D shape, but both sensors need to be able to see it. So those 2 sensors are collecting the 3D shape, and then the other camera there is collecting the color information and associating it to those scans. So you can't overscan it. You can keep going over and over it. It's not going to hurt anything. You just want to try to do a good job and fill in everything. So we'll just keep walking around this a little bit more because we really want to concentrate on some of these areas where we've got some really fine detail. kind of roll that scanner around, make sure we're getting it all in there. But again, it's pretty easy to use. And at any time I can stop, check it out, and continue scanning. So let's go ahead and do that for a minute. So let's go ahead and stop the scan. And then we walk over here to the software and I hit stop scan, and that's going to process it. Now it's not going to do that finalize like we talked about earlier. That's going to apply some additional settings like that hole filling, maybe decimation, things like that. But this allows us to quickly stop, and again, because we're using directly accessing that GPU, we can stop and look at this and look for maybe areas that we've missed. So we could say, hey, I didn't get under here yet, and some other things. Now, a couple other nice things we can do, for example, is I can come in here and I'm going to say remove background, and that's going to create a clipping plane, and it's going to look for what it thinks is the table, right? Which in this case is this rotary table we're using. And you can see it did a pretty good job of finding it, but I can also then move that up or down. So let's put it up just underneath our drill and hit create, and we'll tell it that we're going to manually finalize later because we want to keep scanning. So what it's going to do is create this clipping plane, and basically anything underneath that, it's just going to delete. Now, obviously those triangles are still there, and we don't want those, so now I'm going to go in and do some additional editing. I'm going to select the drill itself because that's the easiest thing to do. And then I'm going to invert the selection, and then I'm going to go ahead and delete those triangles, okay? So, you can do that. Now, if I continue scanning, it's probably going to start picking them back up again. Normally, I might just do that at the end, but you get the idea. You can do some basic editing of the scan data and then continue scanning. So we built this clipping plane, and now we've deleted those triangles. Now our targets are still there, and now we can go back and continue scanning. So it's nice that you can start and stop scanning, and again, as long as we save that session file, we can always go back to that raw scan and continue scanning. So you'll see the clipping plane, it will not pick up the data, but we will start picking up our triangles again. And we can do that one more time before we finish and finalize. So again, I can kind of roll up, try to get up underneath the chuck and up under the handle where I didn't have data before, and fill that all in. So again, you can start and stop at any time. Now typically when we're done with this, we're going to save this file in a couple formats. If we don't care about color, we'll just save an STL file. And if we do care about color, we'll save an OBJ file, which will have associated texture maps with it. And typically, you're going to go to some downstream software once we're done. So if you're doing reverse engineering, you might go to some reverse engineering software. If you're doing more digital sculpting or simulation or animation or some kind of analysis software, you can, again, either output an STL or an OBJ file. And you can also use this for inspection, depending on your accuracy requirements. The GoSCAN Spark is a fine tool for inspection. I mean, if you're not looking for critical, metrology, ISO certified tolerances, this is more than adequate for most people's, requirements. 0.02 of an inch is quite good. So once we're done, we'll go ahead and hit the button again, and we'll let it stop processing, and then we'll go ahead and do the finalize. So again, if we want to do any of those commands we talked about, we'll go ahead and do that, and then we'll take a look at the final data. So again, we can look at it, determine if we want to change anything, and then do the finalize process. Okay, so it looks like it's now finished, and if we take a look, you can see it looks really good. Let's kind of rotate around. Color looks great on the part. You can see all the features. But let's go ahead and turn the texture off and see how that underlying scan data looks. And you can see it looks pretty good. Picked up all the texture, picked up the detail in there, picked up this grip or knurling on the chuck itself. So overall, at that high resolution, it did really well. So color is nice, but it can be deceiving at times. If you look at the color, sometimes you're not really getting a good look at the detail. So we can turn off that texture map and then take a look underneath. And then if we wanted to export this, save it, of course we can save it as an STL file, but we also can save it as a OBJ file. And what that'll do is save the OBJ file but also save the associated texture map as a bitmap or a .bmp file. So you'll have both of those. So if you load it into another program, you'll not only have that high quality mesh, but you'll have the texture map that'll wrap around it so you have that exact same color. So that's kind of showing scanning kind of high resolution and color, high quality color all at the same time. Okay, so this wraps up the video on the new Creaform GoSCAN Spark 3D scanner. Now the Spark scanner takes all the high resolution and accuracy of the GoSCAN 20 and the ability to scan large things with that bigger field of view of the GoSCAN 50 and puts them both together in a great new scanner that improves upon even those features. It offers even better data quality, better accuracy, better color, the ability now for the VX Element software to directly access the GPU card, and a host of other features really make this a great scanner. So if you'd like to learn more about it or maybe schedule a demonstration, visit our website at www.ems3d.com.